Okay, example 2 of the sine law. So, given triangle DST with angle D equals 47 degrees, side length D equals 7.8 centimeters, and S equals 10.6 centimeters. Find the measure of angle S. And they don't give you a diagram, so it's up to you to come up with your diagram. And the more accurate your diagram looks, the less likely you will be to make a mistake in your reasoning. So let's think about this for a minute. I'm looking for a triangle DST. An angle D is supposed to be 47 degrees. Length D is 7.8 and S is 10.6. So I'm going to draw a triangle, a non-obtuse triangle, because I have a feeling this will be a non-obtuse triangle, but that was an assumption I made, and I'll change that if I have to. So when I say non-obtuse, that means no angle is greater than 90. And so I'm going to call this triangle. I want S to be longer than D, so I was about to call this D, but that would probably be a mistake because the longest side probably looks to be this side. So why don't I make this S? So that'll be 10.6. Why don't I make this D? That'll make this 7.8. And then this will be T out here. So my triangle is DST. And angle D is 47 degrees. Now your triangle may look completely different. It might be turned around. It might have D down here and S over here, or D down here and S up here. It doesn't matter. As long as D is 47 degrees. As long as the side opposite S is 10.6 centimeters. Not 10.6 centimeters, but labeled 10.6 centimeters. And as long as this is labeled 7.8 across from the angle D. So the question that they're asking us for is to find angle S. So I look at this question and I see that angle S, I happen to know the side length opposite it, which means it's a contender for the sine law. I know this angle and the side opposite it, so it's definitely a sine law contender. So I'm going to say that sine of angle S over top of the side length opposite it is equal to sine of 47 degrees over the side length opposite it. And I'm not going to bother with the third ratio. I don't need it. I've got one unknown. I know everything else, so I'm going to stop there. So sine of angle S is going to be equal to 10.6 times sine of 47, all divided by 7.8. Doing some work, I'm going to come up with 47 sine times 10.6 equals, divided by 7.8 equals. Now this decimal is this, but I want the sign of this decimal. Now if I round this decimal, my answer is going to be different than the back of the book and different than everyone else in class. So I need to be careful with that. But what's really happening here is I've got sine of S is equal to this whole decimal. Now writing it out is a waste of time. I'm not going to do it again. I'm just doing it so I can show you. What I want to do is I want to find angle S. And angle S is equal to the inverse of that ratio, that decimal that we have. And again, I'm not going to write this ever again. Do you see how it's in my calculator? I'm going to keep it in my calculator. I'm going to hit second function sine, so I'm doing the inverse. And it gives me the answer right away. So my angle S is equal to approximately 84 degrees. I rounded it to the nearest degree. But do you see how I did that nicely? I kept it all inside the calculator. And this, I really wouldn't be writing. I don't think I'll write it again. But if you wish to, you can. I'm going to stop there and we'll do example 3.